Hello everyone, myself Dr. Manoj Kumar, working as an assistant professor in Department of EC at MLR Institute of Technology, Hyderabad. Today I am here to deliver a lecture talk on digital multimeter. This is overview of my presentation. First of all, I would like to discuss the basic concepts, classification of a digital multimeter, how to construct a digital multimeter, working principle, and finally some of the application of digital multimeter. What is digital multimeter? Already we know that it is a device which can measure the voltage, current, resistance, etc. Apart from voltage, current and resistance, it can be used for some other purpose also, like short circuit condition test, diode testing, transistor testing. Some additional features of multimeters are also there. But basically we are going to discuss here about the digital multimeter that can measure voltage, current and resistance in a circuit. What is its importance? It is used in the electrical engineering and troubleshooting, and many for industrial purpose also we are using the digital multimeter. What are different types of digital multimeter? Digital multimeter are basically of three types. First is that handheld multimeter. Then we have bench multimeter. Then we have clamp meter. Handheld multimeter are portable. Bench multimeter have the characteristics that it is very highly precise and accurate. And clamp meter is that it can measure the current without breaking the circuitry. So clamp meter, bench multimeter and handheld multimeter. These are three categories of digital multimeter. What is the function? Basically I told that digital multimeter can measure the voltage AC or DC. Then it can measure the current in a circuit. It may be AC or DC. Resistance measurement, continuity test measurement with beep sound, diode testing mode. It has also a diode testing mode. Frequency measurement. Some of the advanced digital multimeter are used to measure the frequency of signal also. Some other features is that it can be also used to measure the capacitance of a capacitor, temperature, etc. So these are some of the important features of a digital multimeter. What are the key features of digital multimeter? Why you want to use? It is compact and portable. First feature is that digital multimeters are very compact and portable. Second feature is that it is very highly accurate and reliable. And third thing is that it has digital display. So human taking observation in the digital multimeter is very easy as compared to traditional meters. Then it provides multi-functionality. It can measure, already I discussed, it can measure the voltage, current, resistance, continuity, diode testing, transistor, capacitance, temperature measurement, frequency, etc. And the final feature is that it has auto ranging and manual ranging capability. It can adjust its range depending on the input signal magnitude. What are the basic components of a digital multimeter? First component is display, which will be used to show the reading. Second thing is that selector knob. Selector knob is used to choose the measurement mode like voltage mode, current mode, resistance mode, diode testing mode, frequency measurement mode. Then we have probes. Red probes usually positive and black one is negative probe. Then we have ports. COM port means common port, voltage port, current port, etc. So this is the basic overview or basic block diagram of a digital multimeter. Here we can see that we have buffer amplifier, constant current source. Then we have calibrated attenuator. Here current to voltage converter for DC. Then here we have attenuator. Then here we have a rectifier circuit. So basically 5 blocks are very important: constant current source, attenuator and rectifier. These 4 blocks are very much important, and we will discuss the working of each block. Here we have analog to D converter. So whatever the signal generated at the final, before the final stage, is converted to digital data, and digital data is given to the digital display for the final display. So how to use a digital multimeter? Ensures that device is powered off before connecting. Use proper probes and settings. Set the measurement type. Select the voltage, current or resistance mode depending on your need. Then connects the probes, red to positive and black to the negative. Read the display and you can take the measurement value. So digital multimeter is quite easy to use. Working principle. Basic components in operations are input sections, where the probes and connectors are used to connect the input of the electrical signal. Then we have range selector switch. We select the desired measurement type like voltage, current, resistance, range, etc. Then we have signal conditioning circuit, which will convert and process the input signal into a measurable format. Then we have analog to digital converter, which will convert the conditioned analog electric signal into digital signal. Now finally, we have a display unit to display the numerical value of the measured quantities. What are the applications? It can be used in the household, automotive, electronics, industrial, etc. So here we will have more discussion on the working. Constant current source. Suppose you want to measure the resistance. So we will put the switch in the resistance mode. So this constant current source supply the constant current irrespective of load. Like we know that voltage source. What is voltage source? It will provide a constant voltage to the load irrespective of the load. Whether you connect 1 ohm or 10 ohm or 20 ohm across a battery, that will show the fixed voltage. Like that, we have the constant current source in the digital multimeter, which will provide a constant current irrespective of load. Suppose we want to measure a resistance. So what we will do? We will connect the rotatory switch to the resistance mode, and we have to connect a resistance here and here. We will connect a unknown resistance. So the constant current source will supply a constant current through the resistor, and some voltage will be generated. As we know that V equal to IR. So R is unknown resistance here, and this is constant current source. So if you apply constant current source, obviously there will be some voltage drop across this resistor. So if resistor is less, there will be, resistor has low magnitude, there will be low voltage. If resistor has high magnitude, there will be high voltage across resistor. So this voltage is passed through the buffer amplifier, which holds the voltage for some time, and after that this voltage is converted to analog to digital display, and after converting to analog to digital converter, the final value of resistance is shown on the display. So what is happening? There is a resistance, unknown resistance, and a constant current source. So when this constant current source is passed, a voltage is generated across it, and this voltage is directly proportional to the unknown resistance. So resistance value is directly calibrated in terms of voltage, and this voltage is displayed here in terms of some numeric value. So in this way resistance are being measured. For AC voltage measurement, what is happening? First, AC voltage is being attenuated to some safe level. Attenuation means to lower down the amplitude. After lowering down, it is passed to the rectifier circuit. Why it is passed to the rectifier circuit? Because rectifier will convert the analog AC signal to the DC signal, and after converting to DC signal, it is converted to A to D converter. Because A to D converter only understand the DC voltage, that's why we have to apply rectifier whenever we are measuring the AC signal. So this is the basic concept. Now in this way, suppose this is the AC voltage. First it will be attenuated. Attenuated means lower down the amplitude, then pass to the rectifier circuit, then convert to then pass to A to D converter. It will convert to digital format, and finally the numeric value of voltage will be displayed. So this was the working procedure of voltage measurement. Now for current, suppose if you want to measure any DC current, so connect the rotatory switch here. Whenever you want to measure any current, first you convert current to voltage. Why we are converting current to voltage? Because finally this voltage will pass to A to D converter, and already I told A to D converter only understand DC voltage. So whatever, if you want to measure current, convert it to DC voltage, and this DC voltage will converted into digital data, and finally this digital data will be displayed on the digital display. So here I will be converted to voltage and then pass to A to D converter, then display. This is the technique of measuring the input current in terms of voltage. So whatever we are giving input to the digital multimeter, the primary thing is that we have to convert it into DC voltage, then pass to A to D converter, and then finally numeric value is being displayed on the digital display. So these are the certain method to know how the resistance is being measured, how the voltage is being measured, how the current is being measured in the digital multimeter. So this was the simple working principle of a digital multimeter. So in the application we can see that it is used in the household circuitry, automotive sections, electronics, industrial for maintenance of machinery, etc. Thank you.